Hey guys, Coach Sharf here. Welcome back to my YouTube channel. Welcome back to the second practice test. So today we're doing the next 8 problems 9 through 16. Trying to keep my mind on stuff. As y'all can see, I got my Braves jersey on. It's supposed to be opening day today. So I decided to throw that on in honor of that. Just try to remember past seasons, opening day if you're a baseball fan, NBA. Season will be winding down the last couple of weeks right now, getting the playoffs. Go back and watch some old NBA games on YouTube just to pass the time. I've been doing that with some baseball games and some Georgia football games. But anyway, let's get started. All right, so problem number 9. The diagram shows the rectangle ABCD with diagonal BD. What is the perimeter of rectangle ABCD to the nearest tenth? So, we know the diagonal is 12. This is 30 degrees. That's all we got. If you think about this, this is really 2 right triangles, right? Right angle there, right angle there. So, focusing on this right triangle, I know this angle is 30. The hypotenuse is 12. So, I could use opposite and hypotenuse sine to get this side, adjacent and hypotenuse cosine to get this side. But I'm going to show y'all a little shortcut, but then I'll go back and do that as well. So this is one thing we kind of skipped over. I was going to go back and show it after the EOC. When we were talking about sine, cosine, tangent, there's 2 special right triangles. Right triangle where the angles are 45, 45, 90, which of course would be an isosceles triangle because 2 of the angles are the same, and a 30, 60, 90 right triangle. On a 45, 45, 90 degree right triangle, let's say the legs have a measure of x, so both legs are 5 centimeters. All you gotta do to get the hypotenuse, yes, I've been out of school so long, I misspelled hypotenuse, I had to scratch through it, it's okay. You would multiply x times the square root of 2, so 5 times the square root of 2. And you would get whatever that number is, okay? So for 30, 60, 90 triangle, if the short leg is x, the long leg is x times the square root of 3, and the hypotenuse is 2 times x. So we can kind of work backwards from this, okay? If the hypotenuse is 12, we're going to say the short leg, this one, if this is 2x, this has to be x, so x must be 6 divided by 2, okay? So then that means that the long leg is 6 times the square root of 3. Okay? So 6 square root of 3. And let me punch that in the calculator real quick. Because as y'all can see, we need decimal. So 6 square root of 3. It's going to give me 10.4. So I'm going to say 10.4. Okay? Being a rectangle, this is also 6. This is also my 10.4, or 6 times square root of 3, however you want to say it. So I've got 20.8, 26.8, 32.8, which, what do you know, that is one of our answer choices, all right? So if you did want to use sine, cosine, and tangent, let me draw that out over here real quick, okay? So you would have had, yeah, I'm trying to draw this looking at the video through my phone, so it's a little tough. Okay, so we'll say that that's x. Again, if we're thinking sine, cosine, tangent, this is the hypotenuse. This is the opposite side. This is the adjacent side. We'll go ahead and make adjacent y. So get x, I want opposite over hypotenuse, which is sine. So I've got sine of 30 equals x over 12. Since x is in my numerator, I just throw the 12 out in front. So I've got 12 sine of 30 equals x, which will give me 6. Sine of 30 is 0.5. So that would give me 6. Okay, now to get the y, it would be adjacent over hypotenuse, which is cosine. So cosine of 30 equals adjacent over hypotenuse. Again, throw the 12 out in front, and you will see that you will get your 10.4. So I got the same thing either way. All right, number 10. Quadrilateral ABCD is graphed on the set of axes below. Finger getting in the way, sorry. When ABC is rotated 90 degrees in a counterclockwise direction about the origin, its image is quadrilateral A prime, B prime, C prime, D prime. Is distance preserved under this rotation? Which coordinates are correct for the given vertex? So when it asks is the distance preserved, the distance between each point, so basically the sides, or the length of the sides preserved. We've talked about this a little bit again with our transformations. Rotations, translations, and reflections all keep the shape the same exact size. Dilations are the one that make it bigger or smaller. So, yes, distance is preserved, so we can go ahead and get rid of those. So, next thing we need to do, let's see if we can go ahead and figure out which one of these is going to be correct. So, we're going 90 degrees in a counterclockwise rotation. So that means we're going this way, right? So if A went counterclockwise, it should come down here to this quadrant. Okay? This quadrant is negative, negative. Both numbers are negative. So if it rotates down to this quadrant, definitely cannot be 6, 2. So you don't even really have to remember how to change your coordinates. All you got to know is that distance is preserved, so distance is preserved, the shape is kept the same. And that if this rotated down to this quadrant, this had to be negative, negative. This wouldn't. Again, this is negative, negative. This one's negative, positive. This one's positive, positive. This one's positive, negative. If you want to double check it, B rotates over here, negative, positive, negative 3, positive 4. So D is my answer. All right, number 11. The diagram below, the area of the shaded sector, LOM, is 2 pi centimeters squared. We just got done doing this, all right? If the length of NL is 6 centimeters, what is the measure of angle N? So this is where this one gets fun, guys. All right, we gotta mix some stuff in here, okay? So we're not looking for the measure of angle O, we're looking for the measure of angle N. So this is what I gotta do. First thing is, again, we're doing area of a shaded sector. When we're talking about that, we want the radius, right? NL is 6. The whole thing is 6. So that means the radius is 3. Okay, so if I know the area of the sector, I know the radius, that means I'm trying to figure out this angle, okay? If I figure out this angle, whatever this angle is, this is a central angle, so it's going back to that as well. This arc is that number of degrees. And then if I look, angle N up here is an inscribed angle. The angle is on the circle, opens up to the same arc, so this angle would have to be half of this arc, consequently half of theta, because the arc and theta are the same. So how do I get theta? Well, it comes back to the area of the sector. I know the area of the sector is 2 pi. So let's look at our formula sheet. The formula for area of a sector, in case we don't remember, pi r squared theta over 360. So got pi r squared. Oh, I know the radius actually, so I'm gonna scratch that out. Pi 3 squared theta over, come on, 360. Kind of slid away, 360. All right. So, again, thing we got to think about is this, okay? Again, kind of the same idea. Let's make this over 1 because we're going to wind up cross multiplying. Pi and pi are going to cancel out. I know that, right? So I've got 2 over 1 equals 3 squared is 9. 9 theta over 360. Okay, again, this is 9 theta. This is not 90. 9 theta. So if you want to simplify 9 over 360, you can go ahead and do that. But let's cross multiply because that's the way I've been trying to get y'all to do some of these. I think that's easiest. So 1 times 9 pi, not pi theta. 9 theta is 9 theta. 2 times 360 is 720. Divide both sides by 9. Theta is 80 degrees. There we go. So that means this is 80. Means my arc is 80. So that means N has to be half of that, which is 40, which is one of my answer choices, C. There we go. All right, 12. In the diagram below, ABC is similar to triangle DEF. Again, the one squiggly line without the equals means similar. So when we have similar figures, in this case similar triangles, all the angles are the same and the sides grow and decrease by the same scale factor. Well, how can I get the scale factor? Well, this isn't going to give me the scale factor, but let me back up, I'm sorry. I don't know the scale factor, but I can do a ratio of these sides, and then the ratio of the matching sides on this shape has to be the same. So DE and DF, if we look, DE and DF are all of these. So I got to get a ratio. Which statement will justify similarity by side angle side? So again, side angle side is a congruency. It's also a similarity. If we're doing side angle side, these are the angles. And again, the angles stay congruent. So those are the angles that got to be congruent. So again, by default, we can go ahead and knock out C and D. All right, so now if we're looking at this triangle got to set up equal ratios. So this is going to be 6/8. This would give me 9/12. This would give me 8/10. This reduces to 3/4 or 0.75 if you divide it. So we need whichever one of these divides to 0.75. 9/12 is 0.75. 8/10, of course, is 0.8. So this would be our ratio that we want. So the answer is A. All right, flipping pages. All right, 13. The diameter of a basketball is approximately 9.5 inches, and the diameter of a tennis ball is approximately 2.5 inches. The volume of the basketball is about how many times greater than the volume of the tennis ball? So volume, again, what we left off on. Sorry. What we left off on. Now fingers are getting in the way. All right. So again, volume formula for a sphere, because basketballs and tennis balls are, of course, spheres, 4/3 pi r cubed. So let's go back over here. Okay, first thing I need is the radius. Let's come back over here. Again, it gives me the diameter for both. So to get the radius, I got to take half of both of these. So 9.5 divided by 2 is 4.75. And where are we? 2.5. Again, I'm trying to do this through the camera. It's not as easy as it sounds. Is 1.25. All right. So this is my radius for the basketball. This is my radius for the tennis ball. All right. So let's come over here. I'm going to do for the basketball. I'm going to do 4/3 pi r cubed. So 4/3. I know it's a little blurry right now. Y'all give me a second. 5.75 cubed. All right. So 4/3 pi times 4.75 cubed. Again, y'all can punch in the calculator like this. 4 times pi times 4.75 cubed divided by 3. Again, if you don't remember how to get the cubed, you can ask me, but you can always just do 4 times pi times 4.75 times 4.75 times 4.75. So let me punch that in the calculator real quick. Well, I'll show you how to get the cubed. Well, I got my calculator, I guess, might as well. 4 times, where's pi? Pi times 4.75. And again, I'm gonna hit the caret. It's gonna give me that to the 3rd power. So I'm gonna hit equals, divided by 3. It's gonna give me 448.92. And what was it? It was inches, so cubic inches. All right. Now for the tennis ball, it's the same formula, so I'm gonna have 4/3 times pi times, what was it, 1.25, 1.25, 0.25 cubed. So again, do the same thing, 4 times pi times 1.25 cubed divided by 3. So let's come back here. 4 times pi times 1.25 to the 3rd power. Gives me that. Okay. And I'm going to divide that by 3. Gives me 8.18 inches cubed. So, again, let's look at the question, how many times greater? So, what I got to multiply this by to get this? going in reverse. That divided by that will give me how many times greater. So let's come to the calculator. 448.92 divided by 8.18. 54.88. Rounds up to 55, which is C. There we go. All right. Sorry. The endpoints of one side of a regular pentagon are -1, 4, and 2, 3. What is the perimeter of the pentagon? So the endpoints, if I know the endpoints, I can get the distance using the distance formula. I am going to go back and use the distance formula for that one. I don't remember if it was earlier on this packet or in the previous packet. I think it was in the previous packet. We've gone over this at the beginning of the year. If you don't want to do the distance formula, you can do -1, 1, 2, 3, 4. And then 1, 2, 1, 2, 3. So you could say I go down 1 over 1, 2, 3. So you'd have gone down 1 over 3. There's your right triangle, and then you could have gotten that. But let's actually use the distance form. Okay, so I gotta take the differences of my x's, square them, add the differences of my y's squared, and then take the square root of that whole thing. So again, you gotta label them x1 and x2, y1 and y2. So I'll say that's x1, y1, x2, y2. Okay, so do the distance formula now. It's going to be the square root of x2, which is 2, minus x1, which is -1, squared, plus y2, which is 3, minus y1, which is 4, squared. All right, so I got 2 minus -1, which is going to give me 3 squared, plus 3 minus 4, which is -1 squared. So square both of these. 3 squared is 9. -1 squared. -1 times itself. -1 times -1 is +1. So that gives me the square root of 10. That's the length of one side. Pentagon, a regular pentagon, all the sides are equal. So all the sides are square root of 10. There's 5 of them since it's a pentagon. So I would just add this 5 times, which would give me, again, if we go back to our radicals from last year, there's a pretend 1 out in front of all these, so I would just add the numbers out in front. 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5. 5 square root of 10. Again, if you did this in your calculator instead, you'd gotten the square root of 10, be 3.16. So if I had added 5 of those, I would have gotten 15.80-ish, maybe probably 15.81 actually, depending on the calculator you use, if you didn't round it, if you kept the whole decimal. So anyway, I had to see which one of these was equivalent to 15.8. Obviously it's not A, obviously it's not D. Again, square root of 2 is just going to be 1 point something. So 1 point something times 5 is not going to give me 15. So again, it's got to be B by default. The answer is B. All right, diagram of right triangle ABC. AB is 14, AC is 9. What is the measure of A to the nearest degree? All right, so there's theta. Again, easy peasy. Using sine, cosine, or tangent. 14 is my hypotenuse. That's my opposite side. This is my adjacent side. Using opposite and adjacent, which of course is sine. There we go. Thumb, pinky getting in the way again. So sine of theta equals opposite over hypotenuse. When I'm looking for theta, sine moves over and becomes the inverse. And so theta equals inverse sine 9 over 14. Again, a little trickier in your iPhone calculator. If you got a question, let me know. Obviously, I can't show you all the calculator on this while I'm recording with my iPhone, but I'm going to do second sine, get my, oops, realize that's not frame. So let me do that again. Second sine gives me my inverse, 9 divided by 14. There's that, equals 40. And I have 40, B. There we go. All right, last one. So this one's a little tougher, okay? Again, this is one of the things that we did not get to, the equation of a circle. Okay, it says, what are the coordinates of the center and length of the radius of the circle, whose equation is x squared plus 6x plus y squared minus 4y equals 23. So this looks different than some of these that I've shown y'all before, okay? So going back a little bit, what we're actually gonna have to do with these is complete the square, okay? You see I got x squared plus 6x, I gotta complete the square with the constant there. Same thing here, okay? So it's gonna give me, I'm gonna write it out and then show you, okay? It's gonna be x squared plus 6x blank. I'm just gonna group my x's and y's together. Y squared minus 4y blank equals 23. And the key now is, since I stuck a blank in here and a blank in here, I have to add 2 blanks over here. Okay, if y'all don't remember, completing the square is b divided by 2 quantity squared. For a quadratic, it's ax squared plus bx plus c. So my middle coefficient is b. So here I would do 6 divided by 2 squared, which is 3 squared, which is 9. Here I would do negative 4 divided by 2 squared, which is negative 2 squared, which is positive 4. So I put in 9 up here, put in positive 4 here, put in 9 and 4 over there. So first thing I'm gonna do, simplify all that, gives me 36, okay? Coming back here, again, this is turning into completing the square. So it's x something squared plus y something squared, okay? So again, a few ways to get the number that's over here. You take this sign, bring it down, the middle sign. So bring that down, and then you can either take half of this middle number, which is 3, the square root of that, which is 3. Or when we do the 6 divided by 2, again, that's half of that. So we already got the positive 3 right there. So kind of 3 ways you can justify that. Here, number that goes here, half of 4 is 2. The square root of 4 is also 2, but then I already got negative 2 right there as well. All right, so there's that. X plus 3 plus squared plus y minus 2 squared equals 36. So now I have it in this form. So what we got to remember is the number that's with x is the x coordinate, but I got to take the opposite sign. Same with y, that's the y coordinate, but I got to take the opposite sign. When the number that's on the right is the radius squared. Okay, so my x coordinate is negative 3, because I got to do the opposite of that. My y coordinate is positive 2. Okay, and again, this is actually r squared, right? So 36 equals r squared. Square root both sides. My radius is 6. So I've got center.